All right, this lesson is on 9.4. We're going to split this up into 2 days. One of the things that I would recommend you getting right now is some graph paper. That'll definitely help you as we graph sine and cosine functions here. So, pause, go get your paper, come right back. If not, use a ruler. We're going to have to split up intervals or make intervals, and so you'll see it along the way as we get working. To start off right here, we have some vocabulary. We talked about first off the amplitude. Now, I gave you a little equation there and telling you how do we find the amplitude. It's 1/2 the difference of the maximum and minimum value. Well, the maximum min is based off of, let's go ahead and start right here. I'll have my function that looks like this. And in this function, we have, we'll say the curve goes up to 1 and goes down right here to -1. So if I were to take 1/2 the distance, the difference of the max and min value, that will get me my amplitude, which happens to, if I were to go ahead and take 1/2, multiply this by 1 minus -1, which will end up being 2. That tells me the amplitude is equal to 1. Okay, and if you think right here from the middle, this horizontal line, which happens to be our axis in this part, this problem or example, it's going to go all the way up to 1. It also goes all the way down to 1. This halfway point would be what we consider our amplitude. The periodic function are these functions right here, and they continue to actually repeat themselves. Okay, sine and cosine functions, they actually repeat themselves and keep going on over and over. This would be right here. Now, going into some of the other terms, this first part that I showed would be a cycle. Okay, and it says the cycle is the shortest repeating portion. So what I'm going to do is go ahead and put dotted lines for the rest of the function and show it repeating right here, like so. And it can go both positive and negative, both left and right. And so you can see right here, it's constantly repeating itself. Okay, and so this is an example of the one in solid would be one cycle. This dotted line right here, or the dotted function right here that's drawn, would be another cycle. So one of these, the solid one that you see, that would be a periodic, well, it's a graph that repeats itself. That would be your periodic function. Okay. The period is the horizontal length of each cycle. So how long the actual cycle is from before it repeats itself would be considered the period. Come in 9.4b, we'll talk about phase shift, which is the amount the function will shift horizontally, both going left and to right. Okay, think of like your horizontal shift, and then we have the midline, which is a horizontal line that will go through the middle of the function. In the example that I first showed you, the midline happened to be the x-axis. And so depending on the midline, that will result in our vertical shift going up or down. Now, sine and cosine functions, what I initially showed you right there was actually the sine function. Okay, y is equal to sine x. And in both sine and cosine functions, the domain of each function is all real numbers, because that wave just keeps going up and down, it doesn't stop. It keeps going for infinity, both positive and negative values for x. Okay, the range right here, it differs depending on the amplitude. Okay, so that's where the amplitude is important. It says the minimum value of each function is -1 and the maximum value is 1. Well, that right there is based off of our parent function for y is equal to sine x and y is equal to cosine x. Okay. The amplitude sorry for the little awkwardness there. My wife just happened to knock on my door and needed to ask me something. But carrying on, as we move along in our notes right here, you can see we're at this part where we call amplitude and period. And we talked about those two items, and those are some of the main parts that we need in order to graph these functions. The amplitude right there, very simple equation. Amplitude is equal to the absolute value of A. And the period is equal to 2 pi divided by the absolute value of B. Now, where does A and B come from? It's pretty simple. You could look at our equations right here that I'm circling. Y is equal to A times sine bx, and y is equal to A cosine bx. When you look at all of our functions and think about all the functions that we've covered all throughout the school year, our linear functions, quadratic functions, exponential, etc., right? We all had the same type of equation setup. We talked about in those equations where we had the letter A, we had the letter B, and so you should have an idea that, well, when A is in front of our equation right here, like y is equal to A sine B of x or bx, now that's going to have to do something with our, our output. That's going to have something to do with not only our amplitude, but also vertical stretch, right? When we talk about bx, or that b term, that's our dealing with our input, and then that'll deal with our horizontal, stretch and shrink. So we'll talk about that more so later on in actually 9.4b. But let's take a look right here, and we're going to actually pull out your graph paper, and let's take a look at this first function that we're going to graph. We're going to cover the sine y is equal to sine of x, our parent function for a sine curve. Okay. Now, so let's y is equal to sine x, and if you think about our equation, it's y is equal to a sine b times x, and a is going to be in front of the sine, and if you look right there, there's nothing there. So just like how we don't write when there's nothing there, we said before, it's not 0. A is going to be equal to 1. Because if it was 0, then everything would be equal to 0, right? Any number times 0 is going to be 0. So A is equal to 1 right here. In front of the x, there's a 1 as well. So B is equal to 1. So my amplitude, when we take the absolute value of 1, that is 1. Our period right here is going to be 2 pi over 1, which ends up equaling 2 pi. Right, now, part of the reason why, let's get to our graph. So part of the reason why I want you guys to use graph paper, and whenever I graph these sine and cosine functions, I'll always start with the origin. Okay, we'll draw the x and y axis, and then what I want to do is I'm going to go ahead and draw these intervals out. I'm always going to have 4 little marks. Okay, these 4 marks are going to represent quarters. When we think about earlier on in the chapter, when we talked about the unit circle, and we went from, we'll put a little diagram right here. When we start right here at the initial side, it's at 0. And then when we go all around, it goes from 0 to 360. Well, remember, it also goes from 0, and then hopefully remember that when it goes to 360, that is equivalent to 2 pi. Okay. Well, if you look right here, our period is 2 pi. So what they're saying, or what's going to happen, is that our sine curve will start at 0. It's going to go all the way to 2 pi. So what I'm going to do right here is go ahead and label this 2 pi. Now remember, think about it. I split this up into fourths. So what I'm going to do right here next is that this first hash mark is going to represent the 1/4 mark. 1/4 of what? Well, let's take 1/4 and multiply that by 2 pi. And what that leaves us with is going to be pi over 2. So that's the 1/4 part, right? And if you remember on our unit circle right here, we said that 90 degrees is pi over 2. Next up, what we'll do here, let's take 2 pi and let's multiply that. Think about it. From here to here, this is the halfway mark. So let's take 1/2 of 2 pi. And 1/2 of 2 pi ends up equaling pi, which is the same thing as 180. This is where it's important to once again remember our radians for our unit circle. Okay. Moving on to the last part, we go ahead 1/4, 1/2. The third part would be 3/4, and we'll multiply that by 2 pi. So when you work on these problems, we want to figure out what's the period, and you're always going to split it up into fourths. You multiply to get the first interval, multiply whatever our period is by 1/4. The second part always multiply by 1/2. The third part always multiply by 3/4. Okay, and so that makes this part right here 3 pi over 2. So we have our intervals. Okay, now you'll probably want to make it a little bit smaller later on, or maybe you made it small enough. Because what I'm going to do right here, since we have these parts together, we have our intervals. I'm going to move these further down because we have to draw the rest of our graph. Now, when it comes to the parent function of our sine curve, our sine function, unless it's being shifted left or right, it always starts right here at the origin. Okay, so the first part right here is at the origin, so there's my first point. Okay, so next up is, well, how high is it going to go? Well, that's based off the amplitude. Since our amplitude is 1, what I'm going to go ahead is, at least on this graph, for the sake of space, I'll go ahead and use intervals of 3 and go up 3, and that'll represent 1. I'll go down 3, and that represents -1. So that right there will be our amplitude. And so what I'm going to do here is we start right there at the origin, and I will go ahead and go up to pi over 2, and there's one of our points. It goes up, the function then goes down to pi, there's another point. It's going to continue to go down right here now to -1 using our amplitude. There you go. And then it's going to go back, make its way back on up to 2 pi, and that right there is 1 period. And this right here is our sine function. Remember, it does continue on and on. So if we were to continue on using red, it's going to go right here, go up, back down, etc. Okay. If we go the negative direction, We'll go back down. And this right here would be negative pi over 2. It'll make its way back up right here. That'll be negative pi. Goes back up. Negative 3 pi over 2. And then coming back down right here, this would be negative 2 pi. Okay, so this would be, and this is our sine function. Okay, let's go ahead. Let's try our cosine function. So our parent cosine function, y is equal to cosine of x. Let's do the same things. Okay, we figure out first off, put right here, we want to find the amplitude. Amplitude, well, a is equal to 1 because that's the number that's in front of the cosine. That's not there, but you should know it is equal to 1. And b right here is also equal to 1. So amplitude is equal to 1. Our period is once again 2 pi, right? Because it's 2 pi divided by b, or 1. Let's go ahead. We'll make our intervals, okay? I split this up into fourths, makes it it's the easiest thing to do. The fourth part right here is going to be 2 pi. Okay, let's go ahead. Our amplitude is 1. Actually, let's make, I'll go up 2 units right here, and we'll make this 1 this time around. We'll go down right here, and then we have negative 1. Okay, so the only difference this time, because the intervals are still the same. If the period is 2 pi, then we take 1/4 of 2 pi, and there we have pi over 2. Right, we have 1/4, or sorry, 1/2 of 2 pi is pi, and then 3/4 of 2 pi is 3 pi over 2. And remember, how do I get this? The rest of our intervals, it's by taking the period and multiplying it by 1/4, 1/2, and 3/4 respectively. Okay, so the difference between the cosine and sine function is that the cosine function will start up at the amplitude of 1. It starts up here, and then it will make its way on down. Remember, if that's the amplitude, that is the max. It's not going to go any higher, so it just has to go downwards. So at pi over 2 comma 0, there's our next point. It's going to continue to go down right here, and then at pi comma negative 1, that will be this point right here, and then we'll go, after it hits the bottom, it's going to go back up. At 3 pi over 2 comma 0, there's this function or this point, and then it continues upwards right here at 2 pi comma positive 1. And here is 1 period of our cosine function. And then remember, it does continue on both sides, going up and down. Now, when I draw these by hand, I'd say the easiest way is to take it doesn't matter how big your graph is, how small it is, like the intervals, the numbers. Split it up into fourths, because the last thing you want to do is take one of these little squares and then try to split that up into 1/2 or some weird decimal number, because you are going to be dealing with decimals and funny intervals later on. Okay. So there you have it, your cosine and sine function. Let's go ahead, take a look at our next example right here. So this time we have a few differences, few challenges. We are looking at the equation y is equal to sine 2x. On this one right here, a is equal to 1, and this time b is actually different, and it's going to be equal to 2. All right, so for the amplitude, a is equal to 1, so that's easy. But our period is actually different, right? This time we take 2 pi, we'll divide it by the absolute value of 2, which is 2. So 2 pi divided by 2 is equal to pi. So what's going to happen is, in actuality, it's going to compress. right? Let's say from 0, we have 0 to 2 pi right here. Well, and that's when it's supposed to be going up, down, and back up at 2 pi. What's actually going to happen is that halfway, from 0 to pi, it's going to go up and down between right here. Now, like I said, it's going to be much more challenging if you try to start with, keep the same intervals over and over, like spacing, and change it up as you go along. What's going to be easy is, once again, let's go ahead. We'll split this up into our 4 intervals right here. And remember, this is the origin is at 0, 0. Okay? This all the way out here, 1, 2, 3, 4, this is actually going to be, this time around, pi. Last time we said it was, 2 pi. But if this was 2 pi, and then remember pi was actually right here, then our function would look kind of squished, and it would be hard to write a bunch of stuff down. Not saying it's not possible, but why make things harder than necessary, harder than it should be? So that right there is going to be pi. Well, remember, the rest of the intervals is easy. This first part is going to be 1/4. So we take 1/4 of pi. So we have 1/4 pi, or we can go ahead and put pi over 2. Now this next part right here, actually not pi over 2, because 1/4, it should be pi over 4. This is 1/2 mark. So 1/2 of pi, there we have pi over 2. And then this one right here is 3/4 of pi, so 3 pi over 4. And now we have the intervals split up and separated. The last thing before we plot our points is we use our amplitude. And let's go ahead, I'll go up 2 units and say this is 1. We go down 2 units right here, and that's -1, because our amplitude is 1 up 1, down 1 from, and then what this would be is our midline. Okay? Remember, the sine function starts right here at the center, at the origin, and then we go up. Once we reach the max, it goes back down, back to the midline, then it's going to reach the minimum part down here, and then we go ahead and go back up. And so here we have sine 2x as our function. Let's take a look at, let's go on to Desmos right here, and we kind of put two things together. Okay, let's put the two graphs functions and see what things look like. So we'll start off and show right here, this one in red is our y is equal to sine x function. And so remember, 0, 0, we'll start at the origin. As we move to the right, we go up. Remember, there you go, pi over 2, comma 1. We come back down, we're at pi, comma 0. Remember, if we take 3/4 of 2 pi, then we should end up with 3 pi over 2, and that's what it shows you right there. And then we're at 2 pi. And so there is y is equal to sine x. Now remember, with y is equal to sine 2x, what ends up happening is that it's compressing, right? It's going to be shrinking. And here we see in green, we look at our green function, and right there, remember, one period is going to be from 0 to pi. And you can see highlighted right there is pi, comma 0. 0, 0 is right here. Remember, 1/4 of pi is going to be, it doesn't show it. So let's move on. All right, there we go. Pi over 4. Then right here, this is where 1/2 of pi over 2. And then this is 3/4 of pi, so 3 pi over 4. And lo and behold, it all works out just like in the example that I gave you guys. Okay. All right. Let's go ahead and try another one. No, it's a long lesson. I want to make sure you guys have a good idea of what's going on. So finally on this one, you're gonna see that we have our A term is finally a little bit different. A is equal to 1/3. Right? There's our A value. B is equal to 2. So although in my function, and if we go to our graph right here, I'm going to go ahead and make this, I go up 2 units, I go down 2 units, but going up 2 units, I'll make this 1/3. This right here will be negative 1/3. And then hopefully you realize, look, if I just use one square, no way are you going to be fitting 1/3. It'll be very tiny and microscopic. It'll be too hard to even see anything. So that's why we're making the intervals constant, where I want to make maybe 2 units up, 3 units up, whatever you want, as whatever intervals we need for our amplitude. And let's go to our period. So our amplitude right here is going to be 1/3. Our period, we take 2 pi over 2, and it's pi once again. So we have our intervals for our x, and we have right here, remember, if it's our period is going to be pi, then from 0 to pi, there you have it. The first hash mark is the quarter mark, so we have pi over 4. And the next one will represent the halfway mark. So I take 1/2 of pi, and I have pi over 2. And then right here, I have 3 pi over 4. Okay? Because it's 3/4. So since this is cosine, it starts up at the maximum. So at 0 and 1/3, that's where we start. And then it makes its way down to pi over 2, continues down to pi over 4, then continues down to pi over 2. Then it's going to go up to 3 pi over 4, and then back up to pi 1/3 before it begins to repeat the cycle over and over again. All right. I think right here, you guys probably have a good idea on what to do. If not, make sure you guys come to office hours. All right. See you guys later for 9.4b.